Yeah, so what about yesterday's assignment? So everyone is able to write the problem statements for each and everything. Can we do one by one? Please make it fast. Are any doubts in yesterday's session? Whoever not able to understand, just ask me, just raise your questions. Am I audible? Everyone?
Yes, sir. Yes, sir.
Mhm. Prem, did you complete the assignment? Okay, let me call the names and whatever we discussed yesterday.
Sir, I completed, sir, but it is not correct, sir. Actually, what we are finding is like, we didn't get any perfect relevant information, sir.
Just show me whatever you have prepared. I'm just asking about the problem statements, use cases.
I didn't find any problem, sir, but I done this on cluster. Where is the cluster used and which sequence cluster is used after the classification and regressions? Like this, I got some information,
Okay.
but I didn't find out any problems.
You didn't find any problem means at least did you understand whatever the problems, whatever the assignment I have given yesterday?
Yes, sir. 5 or 10 use cases on clustering and 10 use cases on classification and likewise to regression.
Okay. Okay. Now tell me what is clustering, what is classification, what is regression?
Sir? Classification means is there any target data or column in the required file is called classification, sir.
Okay.
And regression means
Yeah, continue.
yes, that's only.
See, yesterday I explained completely those three basic concepts only for 1 hour. I keep on asking you guys, if you are not understand, just ask me. I will explain again and again, again and again. Why? Because these are the core pillars for machine learning. If you are not able to understand clustering, classification, regression, how can I go ahead with the projects? How can I start implementing the projects?
This only.
Okay, so customer segmentation in marketing, image segmentation in computer vision, recommendation system in e-commerce, document clustering, natural language processing, city planning and urban development, fraud detection in banking and finance, healthcare and patient segmentation. Yeah, can you go to classification?
Yes, sir.
See guys, whatever the class yesterday we have discussed, that is very, very, very important. Why? Because each and every concept we are going to discuss completely based on those three things only. That's why I keep on stressing that much. Nothing will happen if I keep on explaining the concepts. If I'm going ahead, I can complete the things within less time, within 1 month. By this month end, by this next month 15th, I can complete the entire course curriculum. That is not the motto for me. You guys should be in the situation to explain however I'm explaining with you. So in the same format, at least you should be in the situation to explain 50 to 60%. We should match. If you are not understanding, just re-listen the recording session. Why I am uploading the recording session after our session? After within half an hour, 1 hour, I am uploading. You should listen it again and you should practice and you should be in the situation to explain. You are able to you are not able to explain the definition also. You know what is classification, what is regression, but that is not the correct thing. You should explain it. What is classification, what is regression, what is clustering. I explained clearly yesterday. So in the same way, if you don't understand, ask me again. Again, I will explain. Okay. Anyway, classification, sentiment analysis, and social media, emails, spam filtering, medical diagnosis, credit risk assessment, image recognition, autonomous vehicles, fraud detection in finance, predictive maintenance in manufacturing. Yeah, scroll down. Stock price prediction, house price prediction, demand forecasting, weather forecasting, market analysis, traffic flow prediction, crop yield prediction, energy consumption prediction. Okay, tell me what is crop yield prediction problem statement? What are you trying to achieve there?
Some crop yield prediction means forecasting whatever we have agriculture in the kind of crops in the land, sir. Due to the weather conditions and soil quantity, or what are the pesticides we are using, by considering all these factors, how much quantity, how much like in tons or quintals, whatever it is, how much quantity we are going to gain at the end of the cultivations, at the end of the cultivation process.
Can you take some examples of input features and output feature? Do you understand, right? What is input data and what is output data? You got it. Whatever the
Like
problem sheet.
how many acres of land is there, and how many how many tons of urea we are using, how
Okay.
many, like how much time it will take, all those are input data.
Okay.
And expecting the crop in tons is target data.
Perfect. So whatever you have told is, whatever the features you told, it may increase or it may decrease. Now you just told 4 or 5 features, but it will, in the real time, it will go till 50, 20, 50, 100, like that it will go.
Yes.
So that crop yield is one target feature, whatever you have done, like how much tons. So like, so 1000 tons, 100 tons, 200 tons, 500 tons, all these like crop yield prediction. Okay. So now that's perfect. So now tell me definitions. What is clustering? What is classification? What is regression? Whatever you have given examples, that is perfect. Some are 1 or 2 examples are wrong, but anyway, fine. You are able to prepare the things. You are able to prepare the problem statement and you are able to prepare the explanation for that problem statement also. Now I need 3 definitions of three things. Let's go ahead and complete it in 1 or 2 minutes.
Sir, clustering means in my opinion point of view, clustering means some of the group of computers combined as a single segments.
Okay.
Those group of all computers controlled by the one main computer. One main computer is called clustering.
Okay.
Whatever these computers are facing are getting feedback given to the commands. Everything is controlled by the single frame computers.
Mhm. What is classification?
Classification means yesterday, as you explained, is there any target data? Is there any target data or target column in the required file? Is called classification.
Okay. Regression.
I don't know.
Then how did you prepare the problem statements?
Sir?
How did you prepare the stock price prediction, house price prediction, all those things, without knowing the definition of regression?
On Google.
Okay, just stop your screen sharing. Now let's take over to Jasmita. Can you continue?
Yes, sir. I'll present.
Yeah, please.
Sir, is my screen is visible?
Yeah, Jashmita, I can see your screen. First question is, what is unsupervised learning and what is supervised learning?
Okay, sir.
Next, go to remaining definitions.
Yes, sir. We have two types of first is supervised learning and unsupervised learning. In supervised learning, there are two, that is classification and regression. In unsupervised learning, we have clustering and association. So, what is classification? Is classification is nothing but there will be a target data, that is yes or no or true or false statements. Like example, if we take sorry, next, regression. So regression is nothing but for prediction of continuous variables, nothing but like if we predict stock price forecasting, so whatever the stocks present in the previous, and we'll compare with these values and will predict the stock. And clustering, so clustering is nothing but uh, if grouping of objects, like based on similarities, like if we take an example of image segmentation in computer vision, like depend on the color and texture like features, the image will be segmented into the different regions. So this is called clustering. So
Can you take clustering example from retail sector point of view, from sales point of view? Can you give that example?
could you repeat?
So, for example, I do have sales data with me. I do have customers data with me. So,
Okay.
how the clustering will be happened there?
So the data depend on how the customer, whatever the objects he has took, it will be segmented or to the different,
Okay.
and after that analysis might have done.
Okay. So here, however, we have taken computer vision, right? So in the computer vision,
Yes, sir.
normally there will be pictures of human beings like men and women, and
Yes.
cats, dogs, and some other missionary related things, and some
Yes.
other tigers photos and elephants photos and
Yes.
lion photos. All these images, we are trying to group them into respective group. So, for
Yes.
example, if men photo is there, that will be grouped to men. If woman photo is there, that will be grouped to women. So, if cat or dog, same respective group, lion respective group, tiger respective group, like that, each and everything, it will be divided into its respective group. So how it will be divided into, so anyway we will be converting that image into numerical data, right? So we will be having some techniques to convert that image into numerical data. By using that techniques, once if we use machine learning algorithm, it will be converted. Okay.
Yes.
So now we have example, email spam detection, credit scoring in finance, and regression. Okay. Now let's go ahead now. Whatever you said is perfect. So Ram, could you continue? Could you take over and explain what is classific classification, clustering, and regression? Okay, Darshan, can you start?
Yes. The screen is visible, sir.
Yes, yes, I can see.
Sir, clustering is that where we combine the data where similar type, the customer segment, where to identify the customer segment based on the purchasing behavior to the suggestion where we are comparing its control by his past history or some based search history.
Mhm.
and document classification, image segmentation, social network analysis. Means if
Okay.
he is being searched, so if you are seeing in YouTube any related videos, by if you are seeing any one related videos on data analytics, the similar videos will be uh, browsing in the down. It will be showing to suggestion to watch the more videos based on data analytics. Like that cluster is works based on your search history or based on your previous history, sir. In document classification, where it works on the means the previous history of the segment. And
What is classification and what is regression?
uh, if we are trying to predict the target in the future, like class labels like 0, 1, 2, 3, or
Mhm.
yes or no, or
Okay.
satisfied or good or bad.
Okay.
In a one word, where now spam email direction means when if you are getting an spam email, it's just directing that it's not good or it's bad or it's getting rejected, and the user can use it fluently, where he can clear his data by using that classification by dividing it's bad or good. It will be useful to the user, sir,
Okay.
to to attend the call or to attend to read the mail or anything like that.
Okay.
And here also in medical diagnosis, credit score means if you are buying a credit card, it will show us your depending on your credit score, you are in low risk or high risk, or like that. It will predict in one word, sir. That is called classification. And regression is if you are trying to predict the continuous values, like sales values of any land or stock. If you are buying stocks, it will be
Okay.
varying, sir. You can't predict the stocks. And if you are purchasing any land, we have to see our previous history. If the land price was 10 lakhs before 2 years, now we can predict that it may come higher. After 2 years, it has been raised for 5 lakhs. We can predict that after 2 years again it will go for 20 lakhs. That, and in stocks we can't. It will be varying, sir, the land price depending on the situation. That is called
Okay.
regression. In regression, we'll get that house price and stock price and energy consumption prediction. If you are owning an any factory or any industry, there the consumption, if you add a new machine, the electricity bill will be varying, sir,
Okay.
depending on your usage or your past history, like that.
Okay.
And similar like traffic flow prediction means
Okay.
now in the peak hours you will be having a heavy traffic. That prediction will be varying, sir, depending on the situation.
Okay.
On the holidays it will be less, and working days it will be more.
Okay.
And customer lifetime value prediction means like uh, based on the historical purchase behavior, helps the business tailor marketing and suggestions, where predict or we cannot predict based on their previous history. So that's called prediction.
Okay. Perfect. So let's go to some other person. Anybody can start. Tejaswini?
Yes, sir.
Yeah. Could you go ahead?
Can I share my screen, sir?
Yes, Tejaswini. You can continue. We can see your screen. Tejaswini, you can continue.
There are two types in machine learning: unsupervised learning and supervised learning. Supervised learning, they are classified into two types: clustering algorithms, dimensionality reductions. Supervised learnings are classified in two types: classification and regression. Supervised learning, there is no target data. Supervised
See. First complete unsupervised learning, then go to supervised learning. First start with unsupervised. Don't confuse yourself. Don't panic.
unsupervised learning, there is no target data.
Okay.
They are classified into two types: clustering algorithms, dimensionality reduction. Next, supervised learning, there is a target data. They are classified into two types: classification and regression. Classification means we are trying to predict a target feature like numbers, yes or no, question, yes or no, satisfied, not satisfied, good or bad. Regression, we are trying to predict continuous values like sales.
Can you give the examples?
Example. Customer segmentation in marketing, sir.
In classification?
Classification.
Okay, read it again, re-listen the video again. You will get more clarity. And let's go to Karthik. Could you summarize?
Hello.
Yeah, Karthik. Yes.
So can you see my screen?
Yes. Yes.
Sir, they are classified into supervised learning and unsupervised learning, sir. If there is a target data, it is supervised. If there is no target data, it is unsupervised learning.
Okay.
And clustering, it has have only input data, sir.
Yeah.
But classification and regression has input data and output data.
Okay.
Next. Sir, this is about clustering, sir. Case study. We use case studies.
Okay.
Image segregation, medical imaging. These are used
Okay.
in MRI scans and X-ray scans.
Okay.
These are only input data. CT scanning,
Okay.
problems solving. These are providing recommendations on YouTube and Netflix about what the content we have watched, and city planning and traffic. These are done by traffic police and municipality. The widening of roads, and if there is any accident-prone areas, they suggest changes and ask the people nearby areas about what the improvements should be done. And weather patterns, this is done by IMD in India, and air quality index by Delhi about how the air is there and it is breathable or not in Delhi. This is about clustering, and this is classification. Same problems. This is input clustering. Credit score. So this is about credit score. The CIBIL score. If we take loans, if we pay EMI correctly, CIBIL score is okay. If we default the loans, the CIBIL score will reduce. This is examples. And this is about ecology problems. Problems are ecology. Identify the animals that they are endangering in the recent times. And this example is tigers and insects. This is done every 4 years, sir.
Okay.
This is about a regression.
What is regression?
Regression is trying to predict the continuous values.
What we are trying to predict in classification?
Classification target features like label relationship, the relationship between input features and target variable.
Okay. Okay, so let me summarize whatever we have discussed. You can start sharing your screen now. Karthik.
Okay.
Thank you everyone for completing the assignments. See now, before going to any explanation, first of all, you should prepare yourself. So what is the first point I need to explain? What is the second point I need to explain? So first we need to make a note of all the definitions one by one. So if you make a note like that, it will be easy for you to remember and to explain also. So now this is the data set which we have considered for our data analytics. This data set related to some of the cars manufactured in USA, Japan, and Europe. So these car dimensions they have given, like how much cylinders and what is the displacement of the car and what is the horsepower of the car and what is the weight of the car, what is the acceleration of the car and what is the model year, so which year it got manufactured and the name of the company. So what is that company name? So whether it's Ford, whether it's Chevrolet, whether it's Plymouth Fury, whether it's Ford, whatever it is. So the same data set, we can use it. If you see, this is the data set. The same data set, we can use it for clustering and for classification and now for regression also. For these three types, we can utilize the same data set in multiple ways. Now tell me, what is the problem statement we can form for this MPG data? This MPG is nothing but this mileage, miles per gallon. So normally in foreign countries, they will be measuring in gallons only, not in kilometers. So miles per gallon, how much it is getting. So how much mileage it is getting. So now tell me how I can create the problem statement for clustering and for classification and for regression. Anyone can tell. Just try, just use common sense. If it is wrong, also no issue, man. Just
Sir,
try. My intention is like just you need to talk. Yeah.
for clustering the mileage of similar cars means now Chevrolet and Toyota is giving a same mileage. You have to divide it similar mileage.
But you do have multiple values in mileage, right? So you need to prepare multiple groups. It will come very lot of groups. If you see, could you see the filtering here? Whenever I have taken miles per gallon. So can anyone try from different perspective? So it's group miles wise, that is mileage wise grouping is fine. That is also one of the thing. So next, any other thing?
By the
The
company name.
miles per grouping means, for example, if you take 9 as a reference, all the cars giving 9 mileage. So here it is only one car available. Let's take another value, 10. Maybe if you take 9, 10, 11, 12 as one group, we can do like that also. It is somewhere 13 cars. Yeah, someone said, what is the next approach?
By the company names.
Yeah, it is also fine. By the company name. See, some of them, wherever it is ambassador, wherever it is some other company, AMC and Chevrolet Datsun. Here also multiple things come in. What is another thing? What is another approach
Weight.
we can consider?
Weight and
Horsepower and
Yeah, so horsepower, everything we
horsepower.
can consider. So here origin also we can consider. So Europe, Japan, USA. So now what we need to do, what we will be doing, we will be taking this entire data set and we will be pasting here. Sorry. Whatever the data we do have. So this column A, column B, column C, column D, column E, column F, column G, column H, column I, everything we will pass it to the algorithm. Whenever we are passing to the algorithm, we need to tell how many clusters I want to divide. First of all, we should know that and we should prepare that. Or else we need to go trial and error method. Like trial and error method, how it will form. So first you will do 3 clusters. 3 clusters is nothing but 3 groups. Next 4 clusters. So next 5 clusters. Like this, you will go one by one. So wherever the clustering is happening perfectly, that cluster we will finalize. Wherever the data points are dividing perfectly, that thing we will consider. So let us suppose if I want to divide my entire data into 3 clusters. So if I want to divide my data into 3 clusters, so I can consider, so entire USA related cars should group into one color. That is one group. So let us suppose I'm copying entire USA related thing in white color. This is USA color. I was able to group into one cluster. And next, Japan. Same, I was able to cluster into green color. Next, Europe also, I will be able to color into another color like red color. So after grouping, if I clear my entire data set, this is how it is able to convert. So all the USA related cars, I was able to group into yellow colors and green colors and red colors. Like this, in the same way, yesterday also we have discussed, if I am able to the customers, multiple customers into multiple groups. So for example, if one person is using iPhone, one person using Samsung, one person using Redmi, one person using Vivo. So whatever the person using, I was able to divide them. So if the person is using iPhone, if I give any offer on iPhone, can he buy or not? So he will buy, obviously. At the same scenario, if anyone If anyone using Vivo phone, which is 15,000 cost, if I am giving offer on iPhone of 50,000 to 60,000, will he buy that iPhone? He is having that much affordability to buy the iPhone. He cannot buy it. Why? Because his capacity is 15,000 only. If I give offer on 50,000, that is 60,000 mobile offer, he can't buy, he can't afford it. So that's why, based on his affordability, all those things are features. So here, however, MPG, cylinders, display, horsepower, weight, acceleration, model, origin, name, all of them are clusters. So based on all these inputs behavior, we will be converting them into multiple groups. So now tell me, we are able to do the grouping, entire data we are able to use. So here each and every feature is input data. Now tell me, what is the problem statement? I can frame it for classification. Come on, guys. What is the problem statement? I can make it for classification. Just read the data. Just read it. These are all the columns. What is my classification problem statement? I can frame with this data. Come on, fast. What we can predict from this data? What is the problem statement we can use for classification?
And based on the horsepower, cylinder, model.
See, classification means target feature. What is the target feature I can consider here in my data set?
Target mileage.
You mean MPG?
Yes, sir.
Yeah.
What is the MPG value here? I am asking classification. What is the MPG value? What it will be called? All these values are what these
Labels,
values?
class labels.
These are labels or continuous values?
These are continuous.
See, labels means like this categorical data 0, 1, 2, 3, like this categorical data. Okay, na? Like this.
Model, sir, model year.
Perfect. Model year. What you need to do this model year? So can you take this 70 directly to the model?
No, sir, we have to take some 5 years, means 70 to 75, then 76 to 80.
Exactly. Whatever you said is perfectly. So apart from this, why can't you take origin? Why are you guys not able to see that origin? Some of them are related to USA, some of them are related to Europe, some of them related to Japan. And leave it this origin also. Why can't you take the brand? You can predict brand also, na? What we have discussed, classification is nothing but just like predicting the class labels. First, it is in the format of class labels like yes or no, good or bad, satisfied, not satisfied, whatever it is, spam or no spam. So here in the same way, you're getting one country name. Here it is also class label, right? Europe, Japan, USA. Or you can use model year also. So like range 70 to 75, we can take one class label. 75 to 80, one class label. 80 to 85, another class label. So how many classes we will get with this model year data? Let me expand this. So if we take that range, how many class labels we will get? Multiple problem statements we can form. So we need to predict which country the cars are related to it. Which country the cars are manufactured. Like this. This is one problem statement. So another problem statement is like we need to predict which brand the cars are related to. Next problem statement is we need to predict which year the car got manufactured. So let us frame the data for first problem statement. So what is my input data? So till model here, let us take some values on them. So model here, till here, whatever yellow color I highlighted, that is my input data. Whatever I'm going to highlight in red color, this is my target data. Make sense, everyone? Clear? So now the data got framed. So all these features are my input data, and this is my output data. And same, this ESA, Europe, and Japan will be converted into zeros and ones like this. So that is the next phase we will be doing as part of project. So normally we can't pass this categorical data directly, right? So that's why we will be doing like this. So now this is your data. So Europe, it comes to 2. So now your data set is ready. So we need to convert this name also into numerical data. That thing we will discuss as part of the project. So now your data is framed like this. So all these are input data, and this is the output data. So what is the problem statement we can frame by using this data for regression? Now tell me, what is the first problem statement came into your mind? What is the first thing and we can predict by using this data?
Horsepower.
Yeah, horsepower you can predict, and apart from that, everyone mileage. So normally main focus will be on the mileage, right? So by using all these features, we need to predict the mileage. So let us take all these features. So next, this LTG will go to target feature. So if your problem statement is changing, your target feature will change. That is the thing you need to understand. So this is my input data and this is my output data. If you see the two examples clearly, in my previous example, whenever I am doing classification, I am predicting origin. This origin is going as my target feature and this MPG going as my input data. But whenever I am doing regression, this MPG went to the target feature and this origin went to as an input feature. So it's based on the problem statement, the features will change. So we need to predict how much miles per gallon we are getting in cost. So same scenario. So how the machine learning models will work? So once if I am able to train with this data, whatever the data I do have here, right? For example, here I do have this data. I was able to train my model with machine learning algorithms, all those things. So now my model should predict. For example, if I am providing data like this, the same data, let us suppose, I am passing here. So what is the value my model will predict? What is the gallon per, what could be the gallons I will be getting here as a prediction? Tell me, guys. So this value will be predicted by the model. All this input data we need to provide. So this value, whatever the MPG we are getting, we need to predict by using our ML model. What could be the MPG we will be getting here?
$15.
Exactly. Why are you guys thinking? So let us suppose just I am changing little bit values, little bit. So here 9, here 355. So here 166, here 3700. So here 12. So here 80. So here ESA, and here same brand company. Now tell me, just common sense, just try to give some prediction value. What could be the value we can get here by comparing previous row of data and this row of data? What could be the value?
1670.
It could be whatever it is. So we are not machines, right? Either it could be 16 or 17
15
or
to 18.
14, whatever it is. That is fine. Or 14. Why? Because it's, if horsepower is increasing, there may be a chance of decrease in mileage also. Okay, why? Because here we have increased the power, the capacity of the car. So now it is able to reduce. We can reduce it to further also. So like this, by using this data, my model will predict. Okay, so this is how the machine learning models will work. So by taking this input data as a reference, the models will predict. The same scenario will be applicable for classification also. If I provide in the classification, how it will predict. So for example, if I take the same example, now tell me what my model will predict here. In the classification, I have given this row of data. What my model will predict. In this regression, you told it will predict 15. But in this classification, what my model will predict? Whatever the machine learning algorithm.
USM.
Yes.
Exactly. So normally, model don't predict this categorical feature directly. It will predict that respective class label. What is the label for this? This will be called as label. That is LABEL. This will be called as class, and this label 0, 1, 2, 3, all this will be called as label. So what I will predict, that means what machine will predict here?
0, sir.
Exactly. That is perfect answer. So now let us suppose if I take the same example. So here my model will predict. What my model? Exactly. 2 will predict. So this is the difference between classification and regression. So this is how the data will be formed. So all this data will go to the input data, and this data will go to the output data. But in the clustering, how the clustering will divide? So this entire data it will group and it will create one cluster label. So cluster label, like if it is yellow color one, for example, if it is yellow color one, it will assign class label 0, that is 0 grouping. That is it has given some number, 0 number. And next Japan, it will take Japan as 1, same scenario. And next Europe as 2. It's like we are preparing these cluster labels. So like that, whatever the data we are getting, for example, if I am getting any data like this, if I am getting this row of data, so here, what is the cluster number the model will predict? So it will predict cluster number here. So it will predict, it should go to the red color. Like that, the clustering, classification, regression. So in the clustering, there is no target feature available. That is the difference. Clear, guys? Everyone? What do you need to do? You just need to explore some blogs. You just need to read and understand more about this clustering, regression, and classification. So tomorrow, what we will do? So we will discuss one end-to-end project on clustering. So I will explain one project. So tomorrow, everyone available at 11 o'clock. Is it fine for everyone? I will plan remaining guys.
Yes, sir.
Okay. Okay, fine. So tomorrow I will plan 11. At least I need 1.5 hour to minimum 1.5 hour. I need to complete one project. So one project we will be discussing on clustering. Okay, so end-to-end project. So how the clustering will be divided, how the algorithm will be used. So what is the algorithm we are going to use? What is the data set we are going to use? Everything I will explain. See, I can take this data set also as my example. So I can take the same data set. Whatever the data set I have considered, I can take this one also and I can explain this one also. I will take one data set and I will explain one complete flow. Same scenario, I will give assignment as another data set. You should complete that project by weekend. That is the assignment. Okay. So any doubts as of now? If you don't have any doubts, let's continue with. If you have any doubts, let's reiterate everything. We are going to do one project on clustering tomorrow.
Sir, I have one doubt, sir.
Yeah, please.
Sir, in the labeling, it will take indexing like 0, 1, 2, 3, and so on. Sir.
Yeah.
Only takes indexing or also alphabets like A, B?
No. It only numbers only. Algorithms,
Only indexing.
not index, numbers.
Okay,
Machine learning algorithms will understand numbers only. If you have data in ABCDs also, you need to convert the ABCDs into zeros and ones. Okay, now. So that thing will come. So for example, whatever the country name we used, right? Whatever the origin name, whatever the car name, all those things we need to convert into numerical data. Otherwise, machine learning algorithms won't work. Not only machine, your laptop also won't understand. See, if you are getting video means, if you are getting image means, the laptop will understand that image as numbers, actually, in the real-time scenarios. It won't read it. It will read it in the numbers and then it will showcase us in the images. That is the process it will go behind it. Everything we need to convert into numerical data. That is what I used to keep on telling from previous sessions, whether it's ABCDs or whether it's country name, whether it's name, whether it's color names, whether it's car names, whether it's text, whether it's review, whether it's image, whether it's video, whether it's speech, whether it's audio sound, whether it's video sound, whatever it is. We should convert everything into numerical data. Then only the machine learning algorithms or deep learning algorithms or whatever it is, everything will work. Clear?
Yes, sir. Thank you, sir.
Okay then. Okay, guys. If
Sir,
anyone?
small doubts.
Yeah.
Sir, what is cluster label, sir?
cluster labels. So we can define cluster
How to
labels.
find?
So tomorrow during our project, I will show you how the clustering labels will be defined. Okay, now.
Okay, sir.
Once if you see the code, once if you see the project flow, you will understand how the clustering labels. Why? Because the algorithms I itself should understand, right? In my Excel, I was able to showcase you. It is divided into green color, yellow color, red color like that. But the machine learning algorithms should understand this type of data should go to this cluster. This type of data should go to this cluster. This type of data should go to this cluster, right? It should assign some random number, right? That's it is called as cluster label. Okay, na? As tomorrow project we will discuss that thing. Don't worry.
Okay.
Anyone? Anything? Okay then. If you guys don't have, let's adjourn for today. We'll connect tomorrow. Okay, guys. Bye bye.